Okay, so today we will be my screen is visible.
Yes, sir.
Yes. Okay, so today we will be learning a few things. Let us see. I thought that GPIO and ADC it will be covered. So let us see that how far we can how the things we can do. You see, this is the IC. This is the IC AtMega. Anytime anything if you are not able to understand, you can interrupt me and you can ask me. I will not mind. How many times you will not able to understand, you can ask me. So this is the microcontroller chip. This is the AtMega328P, and you see these are the P. P means, say this is PB1. PB1 means that is the port number. Okay, port A, B, C, D, E. This is the port number. So this is basically the diagram of the microcontroller, means the pinout of the microcontroller, and we will be using this. And this is the data sheet of the microcontroller, and we will be following this data sheet. I'll share these things, or you can download also from the internet. And this manufacturer of the chip is Microchip. Now my computer is slightly slow, so you have to bear with that. So normally hope we will be using Arduino IDE because somebody told that they already know it. So that's why I used Arduino IDE, but you can use WinAVR, Keil, or any other things. Anyway, this course I will continue further for digital signal processing, DSP, where we will be learning the 32-bit controller. That time we will use different IDE like ST32Cube and all these things that we'll learn later. But today, for your convenience and as you are already aware, so I am using Arduino IDE, but we will not going to use any library. We will be doing the register wise code. So this is the part where the header files are to be included. So here I am using just one. I am declaring, this is the variable, this is the area for global variable declaration. You know what is global variable? Means that variable can be used anywhere in the program. So this is the main function. As the main function is not returning any value, so it's void. So you see, this is the place before the while one loop. Some area is defined. So this is basically, it is for wherever we will write there, this will be executed once. Means that is basically for initialization. And while one loop, while one is always true. So up to this, whatever we will be writing inside the while one loop, that will be repeatedly executed. And here this is the return, as the function is void, it's not returning anything, so that's why I return 0. And this is the area for define the user defined function. So this is the basic structure of any C language. All of are aware. I think you already studied in your first semester or second semester, you studied C. So now you see here I have used one user defined function called pin configuration. That pin configuration I have used here. So in the pin configuration, you see here some register I have used, DDRD. That is called data direction register D. Data direction means it will define the nature of the pin. If the data is coming from the outside to microcontroller, that means it will be treated as input. And if the data is going from the microcontroller to somewhere outside of the controller, that will be treated as output. So you should remember that if a particular pin is to be configured as output, so that particular pin should be, that particular pin should be, that particular bit of the register should be set as 1. Now you see this 0B is basically for binary. So register D, the 7th pin, I have written as 1. So it will be basically the PD7 pin, it will be used as output. Similarly, for register B, I have used 5, 4 and 0th bit as 0. So this will be treated as output. Now I am coming to the main function. What I am doing? The first, that PD7 I am making high, and all other, these all other things are, you see, double slash means it is hidden, it will not be executed. So first the port, the register D, that means the port D7 I am making high and all other port is low, and I am giving a delay of X. X is defined here 250,000 microsecond. 250,000 microsecond. In the next instruction, I am making that PD7 0, but I am making PD5 as 1 and all other 0, and giving the same delay. Similarly, in the next instruction, I am making PB4 as 0, as high, all other 0, and the same thing I am doing. So now let us open the simulation. And your attendance will be taken after the class. Hello sir. Thank you sir, thank you sir. yeah, but they are, yes sir, everything. Sir, what you are telling sir, what you are telling sir. No sir, no sir, no. Sir, no sir, no sir, you don't tell all these things. It is shame for me sir. No, no sir. Sir, I am happiest to get that sir. Yes sir. Actually, I'll put it in my Chennai house, not here sir. No issue sir, no issues. Because that person, that man, he is doing all of my work in office, all the minor work. That Egambaram, that fellow. Yes sir. Yes, sir. Yes, sir. Yes, sir. Oh. Okay, sir. Okay, sir. Thank you, sir. Thank you, sir. Thank you, sir. No, it is fixed, sir. Everything perfectly fixed, sir. Yes, sir. Yes, sir. That is not an issue, sir. Yes, 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 sir. Yeah. I'll remember you in my whole life, sir. Thank you, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. No, I understood. I understood, sir. I understood, sir. Yes, sir. Yes, sir. No issue, sir. No issue, sir. Thank you. Thank you, sir. Thank you, sir. Okay, sir. I am in a class, sir. I'll call you back, sir. Thank you, sir. So nice of you. Thank you, sir. Thank you. I'm sorry, my associate director called me, so that's why I attended. So, so this is the code. So now microcontroller will only understand the hex code. So I am just converting these things to hex code. So you click there, it will be converted to hex code. Anyway, my computer is very slow. It is an old computer, Pentium computer, so that's why it may take time, but you can do.
Sir, could you please once again where did you click to make it export?
দাঁড়াও, এটা হয়ে নি। স্কেচ, এই যে স্কেচ, তারপরে এক্সপোর্ট টু কম্পাইল বাইনারি।
ওকে স্যার।
That and all, you don't worry. I want only that you are interested. That's all. Remaining thing, everything I will take care. This is my passion. Teaching is my passion. This is the export to compiled binary, this one. Got it?
Yes sir, got it. Thank you.
কম্পাইল করতে মাথা খারাপ হয়ে যাচ্ছে। So you see here, now compiling is done. Now I am opening the Proteus. You click on the chip. If you click on the chip, then it is here the program file it will ask, and this is my these things. I open it. Okay, then I am running it. Run hobe kina jani na. You see, now the LED started to blink with a delay of 250,000 microsecond. So now say I want to make it that delay, I want to change it. I want to change it. You make it 1 second. So 1 second means 10 to the power 6. তাহলে 3 1 2 3 হলো। এবার কম্পাইল করো, এক্সপোর্ট টু হেক্স ফাইল, কম্পাইল হোক। কম্পাইল হোক। Okay, compile done. Now I'll go देखो, now the things are, the light is blinking after 1 second. So this is the first code. So what now I am, before going to the next code, okay, now before going to the next code, I just want to ask, do you have anybody having any question?
Sir, right now we have written the code in C, but in Arduino IDE we can write in different languages, like the Arduino language .ino files also. That can be converted to X file and exported to Proteus.
But that library file, if you are, that's why I am telling, if you are using the library file, you cannot do lot more things, because those libraries are written for only that for playing purpose and all these things. You unless otherwise you knowing the, because why I am telling you these things, because if you learn the microcontroller in this way, then any microcontroller you can able to write the code. But if you are using the library, then you will be restricted, and that so many things you can't achieve using those library. Those libraries are only for playing purpose. Say if you want to generate PWM, inverter, all these things cannot be done using that library. You will be learning it slowly. Once the slowly you are going forward, then you will understand that why we are learning register level code, because that library cannot give you all these things. Any other question? Whatever I have told so far, all you understood?
Yes sir. Yes sir.
Any question? Then I will go for the next.
Sir, how we are naming the codes to this code, like C code?
How we are
naming the codes, like 0B and then the number. You were saying that we are.
Okay. I'll show you. You see, the first LED is connected to PD7. You see here it is PD7. The second LED, it is connected to PB5. Here PB5. Third LED connected to PB4. Fourth LED connected to PB0. Got it?
Yes, this I understood. But in the code we are writing the as in binary 0B and then some 001. How we are changing this PD7 to that?
You see, in the first line I am making the PD7 as high. In the next instruction, the PD7 becomes 0 and PB4 become 1.
Can you present the code once, please?
I am presenting now.
The C.
You are not able to see that?
So this is the
Sir, he asking for the Arduino C code. Yes.
This is the code only, no?
In that portion, we are describing the pins as the binary format.
Yeah.
And how we are defining that? How we are defining or activating that port with binary.
That's why here I am enabling that particular. You can see the code now.
Yes.
Here you see in the first set of instruction, I am making that PD7. This is the 7th bit, na? Port D 0B. Then the 7th bit I am making 1. In the next instruction, that 7th bit I am making 0. But the port B 5th bit I am making high. In the next instruction, I am making the 5th bit 0, making the 4th bit 1. This is the way.
Okay, understood.
Any doubt?
Sir, can we use hex instead of binary?
Yeah, you can use. You just here use instead of 0B, you write 0x. Then convert this entire sequence as hex and put that.
And sir, what is port B, port A? Are they all registers?
Yeah, those are the port registers.
And for accessing the digital pin 0 to 7, we have to do it using port B register.
No, any port. I have chosen port B and D. You can use C. This code you can change the register and you can see the output for all other ports.
If you want to access the 11th digital pin,
11.
If we want to access the D11 pin of AtMega328P.
11 pin I not. Where is the 11 pin?
It's a digital PWM.
Then you have to use the PB3. You see here the digital pin 11 that corresponds to PB3.
Okay, so then we have to access port B, third pin.
Third bit. Yeah.
Yes.
I think already Shayok for all other pin Shayok has been done. Shayok তুমি করেছো না সমস্ত পিন গুলো চেঞ্জ করে?
Yes sir.
So you can one person you can do and you can check the output. This will be once you are handling with this, within 2 days you will be familiar, you will be master. It's my promise. This is nothing. This is the starting. We have to do lot more. It is nothing. When you will be learning, you will be thorough in 32 microcontroller. That is my promise. If you are interested, I am telling you, this is my promise. Acha. This is the second code. So here what I am doing, remaining things are same, but here I am using just one pin register. So what I am doing, so pin B5 and B3 I have used as input, and 0 and 4th bit I have used as output. That's why you see 4th bit and 0th bit it is high. I set it because that will be used as output. You know the difference between logical and bitwise operator. So here this is the logical and this is the bitwise OR. This is the bitwise NOT. So those are the things, logical operator and bitwise operator. You already know, na? You already studied in your C course in Kanitkar book or Balaguruswamy, already you studied. So what is this meaning? This meaning means if the pin B5 means B5, PB5 is high, then this two port will be high, and if pin port B3 is high, then this 2 bit will be off. And not means opposite of high, so that's why we used this. Why we use this? Because simply you can make 0 1 0 1, that in that case all other bit also will be interrupted. But in this case, if you write the syntax in this way, then only that bit will be that bit will be accessed, other bit status will not change. So that's why I use this syntax. You can use your own syntax.
This again.
This, you see, I have used port B5. If the port B5 is high, then port B0 and B4 will be high, or 1. Or 1 means what? Other bit whatever may be, it will be high only. Here and not 1. Not 1 means 0. So if you AND 0 with any other bit, so it will be 0 only. So that's why I use this syntax. Got it?
Yes, sir.
Okay. No, simply you should not tell yes sir. 1000 times also, if you are not able to understand, you can ask me, I will not mind. And if you are exhausted, suppose if you, because if your mind is telling no, I have to, now I am not comfortable, will sit, you tell I will stop there, because it is not like that forcefully you have to learn. You don't, because it may not be comfortable all the time. You can tell me, sir, today leave it, sir, tomorrow we'll see. I will not mind. Okay. But my request is, whatever you are learning, you should learn it pakka. Tomorrow at least I can tell your professors, okay, that student learn it properly. You ask that person anything, he will do. I want in that way. Because Parvi sir also my teacher also. He taught me also. And in my plan, so many other things also, like programmable logic controller, all this course I will include you, which will be very much helpful for you for your working life. That may not be included in your course also, academic course, but that is very needed to get job and all. Because during when I was a student, I felt that is to be learned by the student. So that's why I am taking this initiative for you. Ja baba, এটা তো খুলছেই না। So now you see this circuit diagram, what I was telling. You see, this is the PB5. So one push button is connected and this voltage is 5 volt. Okay, because this microcontroller will work in 5 volt logic, and another push button is connected to PB3. So if I press this push button, this LED should glow, and if I press this push button, LED should go off. This is only we are going to do, we are trying to do. So I am compiling it. You see, now if I press this button, you see the LED is on. If I press this, it is off. On, off. So this is the purpose of a general purpose I/O. When you are going to do, when you will be going to industry, there you need to handle the digital I/Os, digital input and outputs. Lot of digital inputs are coming. There will be interlocks. When we are going to on some system, it will check lot of interlocks, and after checking only this, your output will enable. Simply when in the aircraft or the nuclear reactor, where there's lot of safety aspects are involved, so lot of input, it will check some status of the system, and based on that only it will allow the operator, even though he is pressing, then only the output will be energized. So that time you have to collect all the input and outputs. You have to put in. You studied Carnot maps. Hope you all studied Carnot maps. Digital electronics you have studied, na?
Yes sir, K-maps we have studied.
So you have to put into K-map, and based on that you have to implement the logic. So this is the code for on off, because this is a very simple thing, simple way I explained. So this is all about the second code. So any doubt about this code? Are you all comfortable what I am telling, or I have to tell much more details?
It's understandable, sir.
Okay. So for this code, any question? Anybody having any question? Somebody should tell that yes or no, then I can go for the next.
No, sir.
Okay. So shall I proceed for ADC, or I will stop here?
Okay.
Huh?
Sir, can we go for dinner? I mean, problematic. Late.
Okay. No issue. So then we'll ADC, because that need more register. Here only 1 or 2 register. So for ADC, it is required much more registers. So that we will plan for the next session. So before going to your dinner, let me take the attendance. Then you go. Just it will take only 5 minutes. So one person just you turn on your video and you tell your name. I'll just 2 minutes, I'll note down one by one. Preet, you turn on your video and tell I am present. That's all. One by one you go. Fatapat. Yeah.
Yes, sir. Yes, sir. Present, sir.
Shayok. You can just turn on because everybody should see everyone. That's why I'm saying.
Yes, sir. Present.
Okay. Then next.
Alok Kumar, present, sir.
Next.
Sir, Sriman Datta present. Sir, sorry sir, my camera is actually not working properly.
Okay, next.
Yes, sir. Songram Desai present. Sir, actually I don't have camera in my system.
Okay, next.
Sir, Arship Ramanik present.
Sir, Saptashi Chaudhary present.
Next. Okay. Abhishek and Sarvesh Kumar.
Sir, Sarvesh Kumar present.
Okay, next. Raj Kumar. Okay, next. Guru Datta.
Sir,
Next.
sir, I'm Pratik and I'm present.
Okay, next.
Prakash Kumar present.
Prakash Kumar.
present.
Srijan. Okay, next.
Obhirup Chakraborty present.
অভিরূপ, তোমার বাড়ি কোথায়?
আমার বাড়ি আসানসোলে।
আচ্ছা, নেক্সট। ওভার। সবার হয়ে গেছে তো? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 আর 2-3 জন বাকি আছে মনে হয়।
Did you mark present, sir? Sarvesh Kumar
Sarvesha present.
Sir, Sanava is present.
সংগ্রাম, হ্যাঁ সংগ্রাম দত্ত প্রেজেন্ট।
Sir, Dotto noise sir.
হ্যাঁ দে দত্ত বলে হ্যাঁ বলো।
Sir, Phonavo actually present, but his mic is not working currently. But he is present. Phonavo goes. Yes.
Okay.
Yes, sir.
Over. হ্যাঁ আমি ওই ইয়েতে ওই এখনই পাঠিয়ে দিচ্ছি ওই ইয়েতে। Okay, after this attendance the final sheet I will be sending to Preet. Preet can correct me, then only I will send to Devashish for endorsement. Okay?
Okay, sir.
Okay, so next session it will be decided based on your convenience, and before starting the next session you should all show me the output by simulation whatever I have shown, then only I will go for the next. So better maybe tomorrow or day after tomorrow sometime as per your convenience you should show me the output, then only I will go for the next ADC.
Okay, sir.
Okay?
Yes, sir.
So shall I terminate the session right now?
Sure, sir.
Okay. Thank you so much.
Thank you, sir.
Thank you. Good night. Take care. Bye.
Thank you, sir.